Today's lesson is on using the chain rule to differentiate composite functions, or in other words, functions that have one function inside another function. Students who aren't familiar with the chain rule may incorrectly take the derivative this way. Recognizing that we have an expression raised to the fourth power, bring the power in front, and decrease the power by 1, applying the power rule. This is actually only part of the correct solution. To apply the chain rule, we will go ahead and apply the power rule as we did in the incorrect method. Getting 4 times x to the 5th plus 4x raised to the 3rd power, but then also multiplying by the derivative of the inside function, which in this case is the x to the 5th plus 4x. So the derivative of x to the 5th is 5x to the 4th, and the derivative of 4x is 4. Now we have the correct derivative. This process is called the chain rule. Formally, it's written as y equals f of u and u equals g of x. Then the derivative dy dx would equal dy over du times du over dx. We see why the chain rule works, because if we cancel the du's, we're simply left with dy over dx. There's also an informal process of using the chain rule, and that is simply saying that the derivative is equal to the derivative of the inside function times the derivative of the outside function. We'll go ahead and try example 2 both ways. First, using the formal chain rule, we need to define a variable u to represent the inside function. U equals x to the 4th minus 6x squared. Now that we have u written as a function of x, we can say the derivative of u with respect to the variable x is 4x cubed minus 12x. Now that we've named the inside function, we can rename the function y as u to the 5th power, because that's what we have here is u to the 5th power. Now, what derivative can I take? I have y written as a function of u, so I can take the derivative of y with respect to the variable u, and that would just be 5u to the 4th. Now, dy dx, according to the chain rule up above, dy dx is equal to dy du times du dx. Now replacing the pieces, we know that dy du is 5u to the 4th. We know that du dx is 4x cubed minus 12x. And then we can substitute back in for u so that we can get the derivative written in terms of one variable. So 5u to the 4th, we know that u is equal to x to the 4th minus 6x squared. So replacing u with x to the 4th minus 6x squared, we have 5u to the 4th times 4x cubed minus 12x. Now, using the simpler InsideOutside method, we have the function x to the 4th minus 6x squared to the 5th power. We'll say the inside function is x to the 4th minus 6x squared. So if I'm going to calculate the derivative dy dx, I'll say it's the derivative of the inside function times the derivative of the outside function. Okay, so the inside is x to the fourth minus 6x squared, its derivative is 4x cubed minus 12x. Now the outside function is the fifth power. Anything raised to the fifth power, when you take its derivative, would become 5 times that expression to the fourth power, applying the power rule. Notice that this answer is the same as the answer that we got using the formal chain rule, but far fewer steps and sometimes simpler to understand. Now let's try example 3. Part A, we'll use the inside-outside method. dy dx equals the derivative of the inside 2 times the derivative of the outside function. Now the outside function is the sine function, the derivative of sine is cosine, and we leave the inside unchanged. So the derivative is just 2 cosine 2x. Now you go ahead and try example B. Pause the video and press play again when you're ready to see the solution. In example B, the inside-outside method also works well. dy dx is equal to the derivative of the inside, that is 6x squared minus x, so its derivative is 12x minus 1. The outside function is the sine function, the derivative of sine is cosine, and again we leave the inside unchanged. Now press pause and go ahead and try example C, which has 3 functions. Example 3 can be differentiated more easily if we rewrite this as cosine 3x squared plus 1. That whole quantity cubed. So now we can see the 3 layers. The inside function is 3x squared plus 1. That function is inside the cosine function, and the cosine function is inside the cubing function. So using the inside-outside method, we actually have 3 levels. So we have the very inside, then we have cosine inside that, and then the cubing function as the outside function. So dy dx, if we start from the inside out, the derivative of the inside is 6x. The derivative of the cosine function is negative sine 3x squared plus 1. And then the outside function, when we have something cubed, its derivative is 3 times that quantity squared. So bringing the 3 down in front, we still have the expression cosine 3x squared plus 1 inside, and now that's going to be raised to the second power, because using the power rule we decrease the power by 1. If we simplify one step, that would be negative 18 sine x, negative 18 sine of 3x squared plus 1 times cosine of 3x squared plus 1 squared. Because this problem has 3 layers, we might also take a look at how this would look using the formal chain rule. It takes a little bit more work, but you can see how the chain rule really works in this case, and the reason why it's called the chain rule. So if we try example C again, y equals cosine of 3x squared plus 1 cubed. Let's first name the inside function. We'll say u equals 3x squared plus 1. That is inside the cosine function, so we can name another function v. v is the cosine of u. And then that is all inside the cubing function, so we'll say y is equal to v cubed. Now the first function has u written as a function of x, so we can say its derivative du with respect to x is 6x. The second function is v written as a function of u, so we can take the derivative dv du, which would be negative sine u. And the third function, y, written as a function of v, we can find dy dv, which is 3v squared. And now we can chain all three of these derivatives together to find dy dx, which is what we want. We can multiply du dv So when we chain all three of these derivatives together, we see again that if we cancel the du's and cancel the dv's, what we get is dy over dx, which is what we want. So now du dx is 6x, dv du is negative sine u, dy dv is 3v squared, and now we just need to substitute back in to get them all in terms of x's. We know that u is 3x squared plus 1, so we'll replace u with 3x squared plus 1. We know v is cosine u, so that's 3 times cosine u squared, but remember u is 3x squared plus 1. And so now I have the whole thing back in terms of x. Simplifying, it would be negative 18x sine of 3x squared plus 1 cosine of 3x squared plus 1, that quantity squared, which is the same as the answer we got above.